I'm Connor Espenshade. I do percussion in my band and do robotics at my brick and mortar school. And here is my astronomy problem of the day. Okay, so part A, if the universe is constantly expanding, would the universe on average be redshifted or blue shifted? Why does this average not apply to all objects, and how will this change over time? And then part B, a galaxy is 1.63 times 10 to the 8th light years away. How fast is it moving away from or towards the Earth due to dark energy? And if it had an absorption line with a rest frequency of 750 nanometers, what would the Doppler shifted frequency be? Okay, so part A, we're going to start out with the Doppler shift. Okay, so the Doppler shift states that objects moving toward the observer are blue shifted. This is because the waves as the object is moving get crunched in on each other. And so this has more frequencies. A greater frequency and a shorter wavelength. The opposite is true for objects that are moving away from the observer. These are redshifted with longer wavelengths and less energy. Well, if the universe is expanding, everything must be moving away from everything else. We know that the universe doesn't have a center, nor does it have an edge. Therefore, every object must be redshifted. However, if objects are moving towards the observer at a faster rate, potentially due to gravity, then they are moving away from dark energy or expansion, then the objects are blue shifted because the overall net change in position is towards the observer. And this changes over time simply by the universe's expansion is not only it's not only expanding, but it's actually accelerating its expansion. So the magnitude of the redshift will only increase over time. Okay, so part B, this relates with the Hubble constant, which states that for every megaparsec of distance, the objects are moving away from each other at 70 kilometers per second, or they have a recession velocity of 7 kilometers per second. So we can convert the 1.63 times 10 to the 8th light year into megaparsecs by doing some dimensional analysis, where we end up getting 50 megaparsecs of distance. We can get the recession velocity from Earth by plugging in this 50 megaparsecs into this Hubble constant to get that this galaxy is receding from Earth at 3,500 kilometers per second. We can plug this then into the Doppler shift equation, where we have the velocity over the speed of light is equal to the Doppler shifted frequency minus the rest frequency all over the rest frequency. And as we plug these numbers in, we can rearrange it to find that the Doppler shifted frequency of a redshift would be 758 nanometers instead of 750 nanometers. And this makes sense because, as we discussed in part A, the objects are expanding. They're moving away from each other, which means they're experiencing a redshift, meaning that longer wavelengths, meaning that the light has a longer wavelength.